Welcome. Let's take a look at evaluating the integral from pi over 2 to pi of negative cosine of x times sine of x dx. The first thing that we should notice when we look at this integral is that if I take a look at the integrand, it's not a basic form that perhaps I have memorized as a derivative. So what we're going to do is we're going to use the technique called substitution to turn this integral into a basic form and allow us to integrate hopefully rather easily. So when we use integration by substitution, we often look for elements of the integrand that could be derivative of another element of the integrand. So for example, I could look at the cosine function, and the derivative of the cosine function is negative sine. So I could choose to let u, my new variable, be cosine of x, and I would be able to substitute in for du rather easily. Alternatively, I could choose to let u equal sine of x, and if I chose u to be sine of x, then my du would be cosine of x, and I would need to leave that negative sign as part of my transformed integral. So it looks like letting u equal cosine of x might be the easiest path to follow. So we're going to let u equal cosine of x. Then my new differential du is the derivative of cosine of x, so that's negative sine of x dx. Now, as we go about transforming our integral into a new integral with the variable u, we also are going to transform our limits of integration. These limits of integration are values of x, and as I transform my integral, I need my limits of integration to be values of u. So we could say if x equals pi, then u of pi equals cosine of pi, and cosine of pi is negative 1. So I'm going to replace my upper limit that was pi with negative 1. If my lower limit, which is x equals pi over 2, then u of pi over 2 is going to be cosine of pi over 2, and cosine of pi over 2 is 0. So as I transform my integral, my lower limit is now going to be a u. At this point, I'm going to take one more step. I'm going to rewrite this integral just a little bit to make it obvious how we are transforming. So that negative sign that we saw here in front of the cosine, I'm going to reimagine this or rewrite this integral so that the cosine of x is my first factor, and then that negative is going to accompany, that negative 1 is going to accompany my sine function. So I'm writing it as cosine of x times negative sine of x. At this point, I can do my substitution. I'm going to replace cosine of x with u. I'm going to replace negative sine x dx with du. So my integral now is the integral from, let's see, my lower limit was pi over 2. My new lower limit is going to be 0. My upper limit was pi. My new upper limit is going to be -1. And then my integrand is u. My differential is du. Now I have a rather simple integral to evaluate. So the antiderivative of u is u squared over 2. We're going to evaluate that between u equals 0 and u equals -1. So we end up with -1 squared over 2 minus 0 squared over 2. Simplifying that, we end up with 1/2. I hope you find this helpful.